Welcome to qnawire.
This is problem 80 of chapter 23. So this question is asking us to refer to the graph provided in the book associated with this reading passage. Here is talking about reflectance. But if you go to the graph, reflectance and transmittance are both put on the graph. So let's just do a quick recap of what those are. So if we define transmittance with capital T and reflectance with capital R, incident light comes in and strikes the window. So if we go ahead and draw a picture of a window here, and this is going to be coated with a thin film. As light comes in, a portion gets reflected. So this as a fraction of what was incident to the light, that is what reflectance is defined to be. The other portion gets transmitted through the material. So let me go ahead and change the color here. So this is the incident light in yellow. The portion that gets reflected, I guess we could put that in dark blue. That's going to be the reflected light. And then we could draw the transmitted light in green. So as a ratio, reflectance, the reflected light is here in blue, summed with the transmitted light here in green. That combines and gives us the incident light. So all the light is accounted for. So the reflectance, as it's just a ratio here of the incident light, the same way that transmitted light is also going to be a ratio of the total incident light. Combined, these two things give us T plus R. They should give us 1. So in the graph, this would symbolize a sum all the way to 100%. In the graph itself, let's go ahead and do a representation of what we have for the graph. We have lambda here as our independent variable, and we have reflectance here as our dependent variable. So we see that reflectance is a function of lambda. And the question is, what is the reflectance for a certain wavelength? And the wavelength value that they want us to analyze is 1000 nanometers. So here you would need to refer to the graph. The graph here measures percentage because reflectance is just a ratio. So a ratio is can be converted to a quotient. The quotient is a decimal, and then decimal can be converted to a percentage here. So it starts at 0, and then it goes all the way to 100, to 100%. So let me type that out. It goes all the way to 100%. Now the graph itself for reflectance looks something like this. There's very little reflectance for the lower wavelengths, and then here over to the higher wavelengths, once we start getting to the infrared range, it all of a sudden spikes all the way up. Okay, and then here you would have to cross-reference this 1000. So if you cross-reference this 1000 on the graph in your book, you should be able to see that this lines up to approximately 70%. So the answer there should come out to a D, 70%. And this is based on analyzing this graph where reflectance occurs for this infrared wavelengths, which are the longer wavelengths. Here notice that when the reflectance is low, the transmittance is high. The point here is that reflectance plus transmittance is going to equal to 100% because that accounts for all of the light. Okay, so this concludes problem 80.